Hello students, today I am going to discuss with you the types of operating system. Here are main 5 types of operating system. Other than these, there are also network operating system, distributed operating system, or you can say the mobile operating system, single user multiple system, multiple user operating system are also there. But today I will discuss the main 5 types of operating system, and the network operating system and distributed operating system I will discuss in next video. So first of all, there are many types of operating system exist in the current scenario. First is batch operating system. So what is the meaning of batch? As the word suggests, batch. See, you all have 60 students in your class, and when you are going to your lab class, you are divided into batch, right? Group A, group B. So group A will go on lab on Monday, group B will go on Tuesday, group C will go on Wednesday. So something like that. So here in batch operating system, we don't have students. We have what? We have jobs. So what is jobs? Jobs is a combination of programs plus input data and control instructions. So you find when you study batch operating system, you find jobs everywhere. You don't find programs, you find jobs mainly, the word jobs. So jobs is the combination of programs, input data and control instructions. These all are including jobs. So mainly what is the main funda of batch operating system actually? Actually, batch operating system is non-interactive. What is non-interactive? Users cannot interact operating system directly. There is a operators in between users and operating system. This operators may be a person, okay. So first of all, in the era of 1970s, the batch processing was very popular. The jobs are executed in batches. When users wants to do some task, then it operates some jobs in between a punched card system. To complete some task, users operates their jobs in between punched card, in which punches are there, and when light passes through that hole, that punches, it would consider as the binary 1, and if light doesn't pass through the hole, then it considered as binary 0. So 104. Here in batch operating system, the input are on the form of punched card and the output are also in the form of punched card. So the users complete their jobs and provide the punched card to the operators. Okay, operators is the person who authorized the working in the batch operating system, as the users can't interact directly to the operating system, right? So, so what will operator do? Operator accept all the jobs and shorts all the jobs according to their need, according to their nature. So all the jobs are divided into batches by the operators. Then operators provided all the jobs to the operating system. See the diagram. So here batch 1 and here are 2 batches are there. So batch 1, batch 2. So operators, so each and every job, all the jobs divided into a single bundle, okay, in a one batch. Here are 2 batches. Operators provide each and every batch to the system. Then what will system do? Operating system process that batch. Operating system process each and every batch. So after completion of the batch 1, after that batch 2 can enter to the operating system. Suppose batch 1 is executing in the operating system. Suppose CPU process the batch 1. Batch 1 is executing in the CPU. At the same time, batch 2 cannot enter to the CPU simultaneously. Operating system access batch 1, and after the completion of the process, then batch 2 can enter the operating system. So The main drawback of operating system is what? First is non-interactive, second is this starvation. So batch 1 first go to the operating system, then process, then batch 2 have to wait until the batch 1 is processed. The system put all the jobs in a queue on the basis of first come first serve and then executes the job one by one, right. The users collects their respective outputs when all the jobs get executed one by one, not simultaneously, right. Next is multi-programming operating system. Multi-programming operating system means, the name suggests that multi-programs, that means multiple processes are there, and so multiple programming is an extension to the batch processing where the CPU is kept always busy. In batch operating system, all the jobs are executed one by one, but in multi-programming operating system, the CPU are always busy. So therefore, multi-programming improves the efficiency of the system. Suppose we have 3 processes, okay, P1, P2, P3, and we have a CPU. So here are the 3 processes and CPU. So after some time, suppose CPU has been allocated with P1, okay, P1 to be executed. So P1 enter to the CPU. So P1 is here. P1 is here. CPU has been allocated to the process 1. So at the same time, after some times, P1 wants some IO devices. So the execution process of P1 is ending. So P1 wants some IO device, that means P1 working some IO operations. P1 busy in working of IO operation. That means what? That means the place of P1 is empty. CPU is empty, right? So after that time, P2 would enter the CPU. P2 would go to the CPU. That means CPU has been allocated to the next process, as there is no process in CPU. After some time, P2 is here. Then after some time, the execution of the P2 is completed. After some time, P2 wants some IO operation. So P2 working some IO operation, IO devices. So working some IO devices, P2 is not there. That means the places of P2 is empty. P2 process is not there in CPU. That means P3 would go to the CPU. CPU has been allocated to the next process. Here are the main problem is, suppose CPU has been allocated to the first process P1. In this scenario, we cannot remove P1 forcefully from the CPU and CPU can allocate P2. We cannot do that, okay. Actually P1 leaves CPU itself when it wants some IO operations. Why there is a problem? There is big problem is that, suppose P1 contains execution times 1 hour. Suppose P1 contains execution time for 1 hour, and after that P2, suppose P2 execution time is 15 seconds. Suppose P2 contains 15 seconds to be executed, and P1 require 1 hour to be executed, okay. So what will happen? So P2 have to wait 1 hour to be executed. Here until the P1 is not executed, P2 will be not there in CPU. P2 have to wait 1 hour. So next is multitasking operating system. So in multitasking operating system, we have multiple tasks, we have multiple process are there, multiple tasks. We have one CPU. Suppose we have 3 process and one CPU. Like multi-programming system, in multitasking system, suppose CPU has been allocated P1. CPU has been allocated with which process? Starting process P1. So, here in multitasking programming, we can remove P1 and CPU has been allocated by next process actually. This is different from multi-programming. In multi-programming operating system, we cannot remove the process until it execute. But in multitasking operating system, we can remove P1 forcefully and we can enter P2 to the CPU. On what basis? On the basis of time slot. Some time slot are given to the each and every process in multitasking operating system. 10 second, P2 is 5 second and P3 2 second. P1 required 10 second, P2 required 5 second and P3 required 2 second to be execute. Then some time quantum 2 second given to the processor. So, what will happen? Suppose CPU has been allocated to the first process P1. Okay. So, what is the execution time for P1? 10 second, right now. So, our time quantum given to the CPU is what? 2 second. So, after 2 second, in 2 seconds CPU have to process with that job. After 2 seconds, we can remove that process. So, P1, the execution process of P1 is 10 seconds and time given to the CPU is 2 seconds. So, after 2 seconds, we can forcefully remove P1 and after that we can insert P2 to the CPU and the P1 is go and prepare for after ready queue. What are the rest time for the P1? 8 second. 8 second is the rest time to be executed. 8 second are the rest time to be executed for P1. Next P2. P2 required 5 second to be executed, but our time quantum is 2 second. So, we can after 2 second P2 will be removed. Then after that P2 will placed after P1. Okay. Then P2 required more 3 seconds to be executed. Then after that P3 will enter to the CPU. So, P3 required 2 seconds to be executed. So, after 2 seconds P3 will be executed. So, execution process of P3 will be complete. After the completion of P3, the next queue, the first process of the queue will be entered to the CPU P1. And if still there is time to be executed for P1, then it will again go to the queue. Multiprocessing operating system. So, multiprocessing means multiple CPU are there. In multi-programming, multitasking or batch processing, whatever, there are one CPU and many more processors are there. But in multi-processing operating system, we have multiple CPUs are there, multiple processors are there and multiple jobs are there. So, in multi-processing, you can say in multiprocessing system, the execution of the programs, execution of the work, execution of the jobs are simultaneously, not one by one. You can say this is a parallel processing. In multiprocessing, parallel computing is achieved. There are more than one processor present in the system which can execute more than one process at the same time. So, this will increase the throughput of the system. So, there is a difference between multiprocessing and multiple computers. Multiprocessors means we have one computer and within that multiple processors are there, multiple cores are there. But multiple computers means individual computers are there, computer 1, computer 2, computer 3, and they are attached to their individual CPU. Next is real time operating system. So, real time operating system means there is a time constraint given to that operating system, some time constraint are there. In real time operating system, each job carries a certain deadline within which the job is supposed to be completed, otherwise the huge loss will be there. Even if the result is produced, then it will be completely useless. So, real time operating system is two types, hard real time and soft real time. Soft real time means the job will be executed within a time constraint. Hard real time means the job must be completed within a fixed time. So, examples of real time operating system, you can say the time bomb and missile launching. So, the application of a real time system exists in the case of military applications. If you want to drop a missile, then the missile is supposed to be dropped within certain precision. So, it is used in like your medical cases or any scientific cases like your missile launching and any medical cases or time bomb. This is the main examples of real time operating system. So, in the next video I will discuss the services provided by operating system. Thank you.